right, so there's a shortcut to everything, and I'm all about making things kind of easier for you. I wanted to show you and go through this paper with you and show you a couple of the shortcuts. So part of the reason why you did the flip grid was to make sure that you fully understood what was happening. But let's go practice a little bit using laws of signs. Remember, this is the formulas that we're going to be using. The only other thing I wanted to remind you about is that no work means no credit. Glancing at my paper, it looks like I'm in all degrees, and so I just want to make sure that I am in degree mode, and I'm ready to go. So let's go ahead and go. Let's go ahead and get some stuff set up. So I'm going to do the sine of 52, love that number, by the way, favorite number in the world, over x, equals the sine of 34 over 10. And it looks like all I have to do is find the missing piece. So all I have to do is find x, and I'm good. All right, so let's see what I get. Let's type this in. 10 times the sine of 52 divided by the sine of 34. And I get 14 points. Roundy all answers to the nearest tenth, 0.1. Nice. Let's do it again. Here's 21 degrees, and I've got a 7, so I'm going to do the sine of 21 over 7 equals the sine of 119 over x. And let's go type it in. So if I'm going to go type this in all in one fell swoop, I can use parentheses. I can do 7 times the sine of 119. Just need to make sure that as I close the parentheses for the 119 degree angle, that I close my parentheses for the numerator, okay? And I'm going to divide that by the sine of 21. And I get 17.1 this time to the nearest tenth, okay? Again, no work means no credit. Doesn't mean that you have to tell me every single teeny tiny little decimal. It just means that you need to show me the setup and how you get your answer, okay? All right, this one, so it looks like I need to find x, and so I know that I can, well, wait a minute. I need an angle that is across from it, and I don't have that angle, so I got to go get it. Okay, so I'm going to do 180 minus. All right, so I have to do 180 minus 45 minus 64, and I get an angle of 71 degrees. So I'm going to do the sine of 71 over x equal to, and then I know this side is 32, and the angle that is opposite is the 64. So I'm going to do the sine of 64. Okay? Hopefully that made a little bit of sense. You know, sometimes you're going to have to do an extra step in there to figure out what a missing angle is or something or other. So 33.7 it looks like. It looks like with number 4 I'm going to have to do that same thing. So the angle that is opposite the 19 is actually this angle over here. So I'm going to have to 180 minus it again to find that missing angle, which is 9 degrees. Okay, so I'm going to do the sine of 29 over 19 equals, and then I'm going to have to do the sine of 110 over x. All right, let's go type all that in. I'm going to do what I know some of you like to do, which is the fraction thing this time. And so this time, as I cross multiply, right, I'm going to do 19 sine 110. Go to my denominator, and I can divide by the sine of 29. So this is just another way to type it in, 36.8. Okay. Numbers 5 and 6. And so here we are. We've got Kevin, Adam, and Dan passing a hockey puck, and we're going to figure out how far apart they are. So how far is Kevin from Adam? So I'm going to be finding the opposite of Dan's side. Okay. And so I need this angle. I got to do the 180 minus thing again. Let's go find the angle for Dan. 180 minus 71 minus 86. Totally random thought, but Dan is the name of my brother-in-law. My sister just had a baby, or had a baby at the beginning of the year. I don't know if you guys remember or not, but that would be her husband. So I'm going to do the sine of 23 degrees over d equals 25 is across from 86. So I'm going to do the sine of 86 over 25 and go figure out what that length is. Another completely random note is that Kevin is the name of my dad. It's my dad's name. It's Kevin. So it's kind of weird to see Kevin and Dan passing a puck together. Probably, first of all, not going to be passing a puck because they don't play hockey. Second of all, you know, that would not be social distancing at this time of hour, right? All right, this time we need Dan and Ken, so I'm looking for the side that is opposite of Adam. So I can do the sine of 71 over A. I'm going to use my 86 and 25 because what if, just what if I got Dan's angle wrong, right? So sometimes that happens. Or what if I get this wrong? So I want to go back to the original problem to go figure that out, okay? So when I get done, I should end up with a 23.7, okay? All right, I'll meet you on the other side. All right, so here is where we're going to be doing the shortcut, and we're not going to be finding what H is, okay? And so this is a shortcut, but what you still need to make sure that you understand is where this comes from. And again, it comes from knowing what the height of those triangles are, okay? All right, but here's what we're going to be doing. So first of all, some very important things to think about, okay? So first of all, the sine function always has a range between -1 and +1. So if you ever do something and you get the sine of an angle equal to 2, no triangles. If you get the sine of an angle equal to 3 something, no triangles, okay? It has to be between -1 and +1. If the sine function is positive, then the angle can either be in quadrant number 1 or quadrant number 2. So this is coming from the unit circle, okay? If the sign is positive, then you know you're up here in quadrant 1 or in quadrant number 2, okay? When we go to find all the other, or to find the other possible angle, we're going to subtract from 180. So remember, this was when in the previous video, this side hinged over and became over here, and it was like that isosceles triangle, and we subtracted from 180 to get that, okay? The other thing I want you to remember and keep in mind as we do this, because this is how the shortcut's going to kind of help us a little bit, but the sum of all the angles should always be 180 degrees. And no triangle can have two obtuse angles. So if that ever happens, you know something kind of went wrong as well. So I'm going to show you how all of this fits. Let's go do number 1, okay? All right, very first thing that I want to do is I want to draw the picture. I want to see what in the world is happening, okay? So I know that I have the measure of angle A to be 50 degrees. So I'm going to go ahead and draw just a generic triangle. I don't even care what it looks like. But I know that this is 50. I know that side AB is 4, and so a side that is touching angle A is going to be a 4, and then side BC is 9. So I'm just going to go ahead and put a BC up here. AB is going to be 4, BC is 9, okay? Okay, so I paused the video really quick because I wanted to bring you back to this table that I had shown you before. Keep in mind that if the side that is opposite of your angle is larger than the side that is next to it, you're going to get one triangle. So this particular problem is only going to have one triangle, okay? And so I kind of want to keep that in mind, but I'm going to show you how some of these things are going to help us, and this shortcut, if you will, are going to help us solve this triangle, okay? So I'm trying to find the measure of angle C, and so that's this angle right here. Okay, so I'm going to go ahead and set this up. I know I'm going to do the sine of 50 degrees over 9 is equal to the sine of C over 4. Okay, I'm going to end up getting that the sine of C, 9 times the sine of C is equal to 4 times the sine of 50. So the sine of C is going to be roughly 4 times the sine of 50 degrees divided by 9. And again, I just want to write this down so if I make a mistake somewhere, I can go back and find it. So I'm going to get roughly 0.340-ish. I'm going to go ahead and inverse sine it so that I can find the angle. Okay, so the actual angle C is going to be 19.1. Okay, looks like, or 19.9, excuse me. So 19.9, okay? The next thing that I want to do, so using this idea of a shortcut, okay, is I want to go ahead and do this idea right here. So I'm going to find the other possible angle, and I'm going to subtract from 180. So in my calculator, I'm going to take 180, and I'm going to subtract 19.9. Okay, and I get an angle of 160.1. So one of my choices is 19.9. My other choice is 160.1. Okay, and what I want to know is this, right? So I totally brain farted. I don't remember that there's only one triangle. I'm going to use my possible answer choices, this idea of a shortcut, and I'm going to see what I get and what happens, okay? The other thing I'm going to do is I'm going to use this idea that the sum of the angles in a triangle is always 180, okay? So I know that if I have a 50 degrees plus my 19.9, I'm going to get an answer that is less than 180 degrees. I have room for an angle up here. If I did 50 plus my answer of 160, I am not going to get something that is less than 180. I'm over 180, so I know that 160 does not work. The 19.9 works, but the 160 does not. So this has one answer, 19.9. Let me show you that again with number 2, okay, or number 8, I'm sorry. Again, I'm going to draw my picture. So I know that angle B is 37. I'm given that angle, or side AB is 47. Side AC is 29. And I need to find the measure of angle C. So it doesn't really matter what you call what. I'm just going to call this A and C and label my sides. So I'm looking at 47. I know that AC is 29. And I'm finding this angle. Okay, I'm not going to worry about the whole height thing. I'm not going to worry about this. I'm nixing this. Okay, and I'm going to just do a short cut. So I'm going to do the sine of 37 over 29 should equal the sine of C over 47. So I'm going to get the sine of C to equal 47 times the sine of 37 divided by 29. Okay, so the sine of C is going to be the decimal, about 0.975-ish, and when I inverse sine it to find the angle, I get that angle C is 77.3. Or I'm going to subtract from 180, and I get 102.7. So it's one of these two. I don't know which one. I'm ignoring the whole H thing, but let's go do some checking. If I take 37 and I add it to 77.3, I'm going to get a number that is less than 180. So that's good. It's less than 180. I have room for another angle A. So 77.3 works. What about 102? 37 plus 102.7, you know, my brain is hurting, right? And so I'm not sure, so I'm going to type it in. Oh, look at this. I get a number that's less than 180. Again, I have room for another angle, and so that also works. And I have 2 possible answers. Okay? Let's do it again. This is so fun. So fun. All right, angle C is 75. Side AB, which is going to be the side opposite of it, is 28. AC is 19. I'm finding this angle in here. Let's do it again. All right, sine of 75 over 28.